Chapter 8, Section 5 is about multiplying radicals. So what we're going to do today is kind of work on simplifying what's underneath the radical symbol to be as small as possible so that we have exact answers without typing into our calculator and getting an approximate decimal. And we're going to do it using this property, and we'll kind of talk about that as we go forward. So the first one is example A. So it's got the third root of 18 times the third root of 12. And what that property that you just looked at says that we can multiply the insides and rewrite it as one radical. So we can rewrite that as the third root of 18 times 12. Okay, so if it's the same root on the outside, you can multiply them together. You do not change the third. That root kind of becomes the label. So that becomes the third root of 216. Well, obviously that's a little bit nicer, so the third root of 16 is 6. Okay, if we had originally tried to do the third root of 18 and the third root of 12 separately, we would have decimals, and then the approximate answers of those would not get us to exactly 6. So it's better to multiply them together and then take the root after that. Okay, so we're going to do the same idea in example B because they're both fifth roots. Okay, that's kind of like our label. So we're going to have the fifth root, and you're going to multiply what's underneath here. So I'm going to do 8x to the third times 4x to the seventh. 8 times 4 is 32. Okay, and then remember when you have two different bases, you're going to add your exponents. So that's going to become x to the 10th. Okay, so now it's nice. Okay, now we do know the fifth root of 32. That's an exact answer of 2. Okay, before we didn't know the fifth root of 8 or the fifth root of 4, so this is a really nice way to get it exact. And the fifth root of x to the 10th is going to be x squared. Okay, so then we can go ahead and move on. Part C. We've got the fourth root of 16, okay, and we know the fourth root of 16, that's already perfect, so that's 2. And the fourth root of n to the fourth, the 4's will cancel each other out, so then we would just get 2n. Okay, so A, B, and C are pretty straightforward examples. Ones like example D, E, and F are where things are going to get a little trickier. Okay, so in example D, I have the square root of 98x to the fourth. Okay, well, first of all, you want to remind yourself that if there is not a number there, that's really a 2. So we don't know the square root of 98, but we do know, hopefully, a perfect square that breaks down 98 evenly. Okay, so right now I'm just going to do a little scratch work. Okay, so I know that 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Sorry, I went one too many there. Is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. And 9 squared is 81. These are all of my perfect squares, okay? And the reason I made them all 2's was because of this 2 over here, okay? And I want to know which one of these answers breaks down 98 evenly, okay? So does 4 go into 98 evenly? No. Does 9? No. 16 does not, okay? And what you should be doing on your calculator right now is 98 divided by 16 and see if that's a perfect answer. 98 divided by 25, 98 divided by 36, okay? And it turns out that this breaks down to 49 times 2, okay? So you're going to go through these, and as you get better at this and you do more of them, you'll start to see what it breaks it down a little faster, okay? But for right now, you can just do trial and error, no big deal, okay? So I can break this up into the square root of 49 and the square root of 2, and then I'm just going to put the square root of x to the fourth at the end. So basically, you're doing the exact opposite of what you did in example A, B, and C, okay, where you're working yourself backwards. Now, the reason we do that, okay, is because you know that the square root of 49 is 7, okay? Well, that's nice. I still don't know the square root of 2, so that's going to stay, okay? And then the square root of x to the fourth, okay? And then people are like, well, how do you simplify that? Okay, you always take the inside number, divide it by the outside, okay? So that's going to be 2. So we get an x squared, okay? So if we kind of rearrange that so the numbers without the square root go up front, we're going to get 7x squared times the square root of 2 as our final answer. Okay, and this is how you simplify roots. And the reason this is simplified, okay, is we started with the square root of 98 and we ended with the square root of 2. Okay, so you want the number to be inside the square root to be as simple as possible. Okay, so we'll try another one. The next one is the third root. This time, I'm not going to start with a square. I'm going to look at all of my third powers. So 2 to the third, 3 to the third, 4 to the third, 5 to the third. Okay, and these are all on those green sheets from last chapter, so hopefully you still have those around because this will be very helpful. Okay, otherwise you just kind of jot down the first few and see what breaks it down. Well, hopefully you realize it's the first one, okay, because 8 is going to break down 80 10 times. Okay, so again, you're looking for a perfect third power that breaks it down evenly, and the two numbers in here, the 10 and the 8, have to multiply to give me 80. Okay, so that's how we're doing it. The inside numbers have to multiply back to what you started with. Okay, it's kind of like a factor tree, just like you did in like 4th grade, only way more complicated. Okay, and then I'll put my variable at the end. All right, so I know that the third root of 8 over there is 2. The third root of 10 I do not know, so that stays the third root of 10. And then we have to simplify over here. Well, on the last one I told you can divide. Okay, and if we divide this time, we get 2/3, which is a fraction, and that's not helpful. So here's my really weird trick. Okay, Mom says, okay, you can't go outside unless there are 3 of you, okay, because otherwise it's not safe. So there are 2 children inside the house, okay, so this is your house. There's 2 children inside, but Mom says you have to go outside in groups of 3. So can any of you go outside safely? No. So you all have to stay inside the house. Okay, now mathematically, how does that work? Because this fraction is less than 1, they all have to stay inside. Okay, that number would have to be greater than 1 in order for you to take any groups out. So my final answer will be 2, okay, because that's the only thing outside the radical, and then everything inside the radical will be the 10 and the x squared. So your final answer here will be 2 times the third root of 10x squared. Okay? We'll try another one. This time we're looking for a perfect 4th power. Okay, so we can try 2 to the 4th, 3 to the 4th. So we've got 16, 3 to the 4th is 81, 4 to the 4th is 256. Okay, so you're looking for one of those that divides evenly into 128. Okay, and that happens to be 16. And 16 goes into 128 8 times. Okay, so you're really going to want your calculator to help you figure this out. And then I'm going to write the 4th root of p to the 9th in its own. Okay, well, the 4th root of 16 is 2. I don't know the 4th root of 8, so that just stays the 4th root of 8. Okay, and then here comes the house trick. So this time Mom says you have to be in groups of 4 to go outside. And there's 9 children inside. That means 2 groups, 2 groups makes that 2 groups can go outside, and that's 8 kids, and that means that 1 is left inside. Okay, so 2 groups of 4 can come out of 9, so p squared, and then 1 is left inside, so 8 plus 1 is 9. Okay, mathematically speaking, that's 9 divided by 9 divided by 4, which is 2 1/4, so 2 comes outside and 1 is left inside. Okay, it depends on which way you prefer. Okay, either way it works out the same, and then we're going to put the things that are outside the square root together. So we've got 2p squared times the 4th root of 8p for our final answer. Okay, so this is tricky. There's a lot of steps going on, but just go one by one and hopefully it'll work out. Okay, g is the 5th root. Okay, now here you could write down a bunch of 5th roots, but here's a little hint. There's 5 zeros. So what probably goes in there? Okay, 1,000. Okay, so I'm going to have the 5th root, of negative 100,000. Okay, and then that would be times the 5th root of 4, right? 1,000 times 4, 100,000 times 4 is 400,000. Okay, and then I'll rewrite my 5th root of p to the 8th. Okay, so just a little hint, if there's tons of zeros, most likely you're going to look for the 100,000, okay, because then that should hopefully break down evenly to negative 10. Okay, and then we'll have the 5th root of 4 stays, okay, and then the house trick. Okay, so got to be in groups of 5. There's 8 kids inside. That's 1 group, and then there are 3 kids left inside. Mathematically, that's 8 divided by 5. That's 1 group, and there are 3 left. Okay, so where are we? So then we are putting the things that are outside together, so the negative 10 and the p, and then the 5th root of 4p to the 3rd, all the stuff that is left inside. Okay, all right, so we'll try one more. So we're looking for a perfect 3rd power. Okay, if you want to list these on the side of your paper, so you don't have to redo it each time. It might be helpful. Or you can use that sheet, or you can really like your calculator, or you can memorize them and be a nerdy mathematician like myself. Okay, so 8, 27, 64, 125. Okay, and you want the biggest one that goes in there evenly. So that's going to be 27. So I'm going to have the third root of 27, and that goes into 54 twice. Okay, and then I'm going to break the variables in separately. So I've got a to the 6th, and then I have b to the 10th. Okay, so now the third root of 27, okay, that gives me 3, and then the third root of 2 stays. Okay, when you do these, always one of them breaks down evenly and one of them does not. Okay, house trick, okay, third root of a to the 6th, so you have to go outside in groups of 3, and there are 6 kids, so everyone can come outside, and there's going to be 2 groups outside. Okay, in terms of the b, have to be in groups of 3. There's 10 kids inside. Okay, so that's going to be 3 groups, but then there's going to be 1 lonely b stuck inside. Okay, again, mathematically, this was 6 divided by 3, so that gave me 2. 10 divided by 3 gave me 3 1/3. Okay, so things that are outside are going to go together. So my 3, my a squared, and my b to the 3rd. And then the things that are left inside are my third root of 2 and my b for my final answer. Okay, so lots of steps. Take it one by one. Okay, and I'm going to want to see all of your work for these problems. On the one-story problem of the day, find the geometric mean. Okay, so we have done arithmetic means for a long time. Okay, geometric means, instead of adding these, hopefully you remember from sequences, we are multiplying. So you need to multiply every single number in here. And then, instead of dividing, you are going to raise it to the root of how many ever there are. So we've got 1, 2, 3, 4, 5, 6, 7 terms. So we're going to raise it to the 7th root of that. Okay, so multiply them all together, take the 7th root of that. So that should get you 33.58. Please make sure that you can get that number on your calculator. Okay, you may be able to find the 7th root button on your calculator, or, okay, on your calculator, just do it to the caret of 1/7. Okay, either one will work fine. Okay, so a little trickier today, so I'm sure there are still lots of questions, and wise people never stop learning, so go ahead and write some questions and bring those to class tomorrow.